This film demonstrates the performance of an automatic muzzle reference system used to continuously measure muzzle pointing angle of tank-mounted gun tubes. Shown here is data taken at Aberdeen Proving Ground by the AMRS instrument while mounted on an M1A1 tank traveling over a rough terrain washboard course at a speed of 25 miles per hour. The AMRS instrument continuously tracks the angular motion of the muzzle. A computer is plotting muzzle angle data sequentially in time on a grid where the X and Y axes are scaled in milliradians and represent the horizontal and vertical components, respectively, of the muzzle pointing angle. The data acquisition rate for the field test was 1,000 hertz, but the computer is now displaying the data 40 times slower, so the viewer can watch the intricate meandering of the muzzle over time. Each data point displayed represents a measurement by the AMRS of the pointing angle of the cannon relative to the trunnion. The scale for this grid is in milliradians. A milliradian subtends 1 meter at 1,000 meters. The capability to continuously follow the motion of the tank cannon muzzle to within fractions of a milliradian, as shown in this film, significantly increases the probability of hitting a tank-sized target several thousand meters away. The AMRS consists of a small mirror mounted on the muzzle, which is viewed by a telescope mounted at the cannon's trunnion. A beam of light projected by the telescope and reflected by the mirror is detected by a solid-state position sensor, which electrically reads out muzzle azimuth and elevation. Developed by Princeton Scientific Instruments under SBIR grants, the AMRS has been field tested on an M1A1 tank at Aberdeen Proving Ground, and the performance and stability of the system under field conditions represent a considerable improvement in the state of the art. The Princeton Scientific Instruments AMRS has significantly wider angular dynamic range and considerably higher frequency response than previously available muzzle reference systems. The instrument has a dynamic range of plus and minus 5 milliradians, a bandwidth of 1,000 hertz, and an RMS noise of 5 microradians. By using an automatic continuous muzzle reference system as input to a tank's fire control system, continuous updating of the muzzle pointing angle can be achieved while the tank is in motion and during rapid fire. Tests done at the Ballistic Research Lab in Aberdeen have shown by using AMRS data that firing accuracy while moving over rough terrain can approach the accuracy achieved when the tank is firing stationary. The Princeton Scientific Instruments AMRS can also monitor muzzle motion while the cannon is firing. The two graphs displayed show the muzzle pointing angle during 2 separate test firings of the tank cannon. The graph on the left shows the muzzle angle motion for a round which was fired a half hour later than the round on the right, but both are now displayed simultaneously here for a comparison. The general path the muzzle takes is similar for both rounds. More importantly, the muzzle angle at shot exit, indicated by the last data point, is nearly the same for both shots. Here is another round set fired 6 months later, showing the same general trend. The significance is that it appears feasible to use the pointing angle information gained at shot exit from one firing of the cannon as a predictor to the muzzle angle deflection at shot exit for the next round. This information could be incorporated into the ballistic solution for aiming the second round, significantly improving its accuracy. The Princeton Scientific Instruments Automatic Muzzle Reference System can enhance the firing accuracy of the M1A1 under all firing conditions, providing the capability to continuously correct for bending of the cannon due to tank motion, thermal heating, and firing.